Good morning students. So today we are going to discuss about ozone, sulfur dioxide. We will discuss their preparation, their physical properties, their chemical properties, and then we will learn about contact process for the preparation of sulphuric acid, and also we will study about the oxyacids of sulfur. Okay, so let us start. First of all, ozone. Ozone, as its symbol implies, O3, it is trioxygen. It's a triatomic molecule. There are three oxygen atoms which make this. Okay. Now we can say this is allotrope of oxygen, and it is having a less stability as compared to diatomic form. Okay, so it is formed from dioxygen by the action of ultraviolet rays and also atmospheric electrical discharges. It is present in low concentration throughout the Earth atmosphere, but its amount is 0.6 parts per million, means 0.6 ppm. This is its concentration in the atmosphere. Now see, this is the structure. Since there is the presence of one lone pair in the central oxygen, so the structure is bent. Okay, so what do we learn now? That ozone is prepared from oxygen by the action of ultraviolet rays, in the upper atmosphere. Now see, diagrammatically you can see ultraviolet rays, when come in contact with oxygen, what they do, they first atomize it. It changes into atoms. Then that atom reacts with oxygen molecule to form ozone molecule. Now this is the reversible process. Again it can be decomposed to nascent oxygen and dioxygen. So that is why we say that this is less stable as compared to O2. So here also it is shown, ultraviolet rays, when they fall on oxygen molecule, it atomizes, and that atomic form combines with the oxygen molecule to form ozone molecule. Okay. Now what are the physical properties of ozone? Now see, when ozone is prepared, it is a pale blue gas. It is having slightly solubility, means it is less soluble in water, but it is having more solubility in inert non-polar solvents, okay, such as carbon tetrachloride or fluorocarbons. Okay, in that it is soluble very properly. Now it exists in the form of blue solution, but at 161 Kelvin temperature it condenses to form a dark blue liquid, means its color depends on the temperature. At what temperature it exists, that decides its color. Normally it is pale blue gas, but if we take it at temperature 161 Kelvin, then it changes to dark blue liquid. Okay, now if we take it at the temperature below 80 Kelvin, then its color changes to violet black. Okay, so what we can understand, normally it is having light blue color, but if temperature changes, then its color also changes. Now let us discuss about the properties of ozone. It is a powerful oxidizing agent. Why it is powerful oxidizing agent? Because it readily changes into this form, O2 and O, and this can be added in any other substance, so it becomes strong oxidizing agent. Okay, now it is unstable at high concentrations, and it will decay to diatomic oxygen. Okay, so this also oxidizes nitric oxide into nitrogen dioxide. Now since it is having oxidizing agent nature, so it changes sulfide ores into sulfate ores. Okay, just like lead sulfate changes to lead sulfide changes to lead sulfate if it reacts with ozone. Now it also shows reducing nature also, means it is having oxidizing nature also as well as reducing nature also. Now see, if we react peroxides like barium peroxide or hydrogen peroxide with ozone, then they are reduced to their respective oxides, just like BaO is formed or H2O is formed. So when there is loss of oxygen from this molecule, from peroxide molecule, then we will say that it has undergone a reduction. Okay, it reacts with potassium iodide and there is formation of iodine. So if we take the solution of potassium iodide, Ki plus H2O means it is the solution of potassium iodide, then there will be formation of iodine. Okay, so iodine will be formed from aqueous solution of potassium iodide. Now where it is used? It is a very important reagent and it is used in many organic reactions. When we have to perform ozonodialysis process, then ozone is only to be taken. Okay, in hospitals also it is used worldwide. Okay, in surgical rooms where surgeries are going on, there to avoid this suffocation we use ozone. Okay, so it is having two types of effect. First is it neutralizes all the bacteria, and second it undergoes dissociation to produce oxygen. Okay, so ozone is also used as alternative to chlorine. Okay, now see, what is the use of chlorine? It is used for chlorination. Okay, in this in the factory of where paper factories are there, there we use chlorine. So ozone can also be used in place of chlorine, and it is having bleaching action. Okay, now it is also used in conjunction with oxygen and hydrogen peroxide to eliminate the need for chlorine containing compounds. Okay, so where chlorine containing compounds are required, if we don't have such compounds, then we can use ozone also in association with oxygen and hydrogen peroxide. Okay, now it has one more important use. It detoxifies cyanide wastes. So whenever there are industries where production of cyanide waste is there, which is very dangerous for health, then the use of ozone will detoxify, it will eliminate the effect of toxic nature of that substance. Now we start with sulphur, the second compound, second element which will be discussed is sulphur. So how it exists? It exists in the form of sulfides, sulfates, or whenever volcano eruption is there, then in those volcanic gases there is presence of H2S gas. So sulphur is also there, and it exists in proteins also. Okay, now in the form of sulfates, it is present in gypsum or epsom or burites or globular salt. Okay, in the form of sulfides, it exists as pyrites, copper pyrite or iron pyrite, or blende or cinnabar or galena. So sulphur is present in so many forms. Okay, now if we discuss now about allotropes of sulphur, then there are three main forms: alpha, beta and gamma form. So first form is called alpha form, or we say it is rhombic sulphur. Now this allotrope is yellow in color, and how they can be obtained? They can be obtained by evaporating the solution of roll sulphur. Means whatever sulphur we have, we will take that sulphur in CS2 medium, carbon disulfide medium, and then we will evaporate, and this will result in the formation of rhombic crystals of sulphur. Now this sulphur is insoluble in water and it dissolves in non-polar solvent like benzene, alcohol or ether. Okay, it is readily soluble in carbon disulfide. Now let us see this structure. It exists as octatomic molecule S8. It is S8 form. So each sulphur is bonded with two other sulphur atoms. And this structure which you are able to see here, it is also known as puckered ring structure, Puckered, puckered ring structure, puckered ring structure. Okay, so this is puckered ring structure and it is S8 unit for rhombic sulfur. Now second form is beta sulfur and it is having melting point 393 Kelvin and specific gravity 1.98 and it is soluble in carbon disulfide. Okay, now this is the structure which is for S8 form of sulfur and this is also known as chair form. This is called chair form or S6 form of sulfur. Okay, if you will see, there are 6 atoms which combine to form a molecule, and so molecule is S6 and this looks like chair, so we say it is chair form of sulfur. Similarly, third type of sulfur is plastic sulfur or gamma sulfur. Okay, now how it is obtained? It is having zigzag structure. What is its structure? Zigzag structure. Okay, now how it is obtained? When we heat yellow sulfur, then it gives a zigzag form of sulfur and that sulfur is called gamma sulfur. Okay, it is like rubbery linear polymer. Okay, so we say it is gamma sulfur. Now two more type of existences of sulfur. One is milk of sulfur. Just like we say milk of lime. Now what is milk of lime? It is calcium hydroxide. Its chemical name is CaOH whole twice, and since it looks like milk, it is white, so we say it is milk of lime. Similarly, milk of sulfur will also look like white liquid, so we have given the name milk of sulfur. Now how it is obtained? It is prepared by boiling sulfur with milk of lime. Okay, first of all, what we will do, we will take calcium hydroxide, we will heat it with sulfur. Okay, then it will result in the formation of calcium pentasulfide and thiosulfate. Okay, these two things will be formed. Now again this mixture will be treated with HCl and there will be formation of milk of sulfur. So ultimately what we are doing, we will heat sulfur with lime water in the presence of acid, which will ultimately result in milk of sulfur. Now see, these are the products formed. Now in this form, what is there? We can see colloidal form sort of thing. Means just like milk is there, that form we will see where sulfur will be distributed throughout the sample. So this is given name of milk of sulfur. Now in case we want to obtain colloidal form of sulfur, then how we do it? We take thiosulfates and we react it with some acid. This will form sulfur, sulfur dioxide and water. Okay, now see here in this case what we have taken? We have taken sodium thiosulfate, we treat it with acid and this forms sulfur. Okay, now here this sulfur which we are getting here, this will be surrounded by so many molecules so that the size of this particle becomes of colloidal range. When it happens, then we will say that we have obtained colloidal sulfur as a result. Similarly, if we take sulfur dioxide gas, if we pass H2S gas through sulfur dioxide, then also there will be adsorption and formation of molecules of the colloidal range, and that also will be termed as colloidal sulfur. So what do we mean by colloidal sulfur? By colloidal sulfur we only mean that the product formed will be colloidal solution in which sulfur will be the distributed form, distributed phase or dispersed phase. Okay. Now how can we prepare sulfur dioxide? Okay, now we have come to third compound, sulfur dioxide. So sulfur dioxide is formed by action of sulfur with oxygen. Okay, when sulfur is burnt in air, then there is formation of sulfur dioxide. Now, in case we have to uh, prepare it at large, then during extraction of ores, during extraction of metals from the ores, there is production of a large amount of sulfur dioxide. Just like if we take iron pyrite, okay, if we take sulfide ore of iron, then on combustion it will form ferric oxide Fe2O3 and sulfur dioxide will also be produced. Okay, if in case we have to prepare in lab, then what we will do, we will add copper fillings or copper turnings to sulphuric acid, and this will result in the formation of sulfur dioxide gas. Okay, so sulfur dioxide is obtained simply by combustion of sulfur. Okay, now this sulfur dioxide, what are its physical properties? It is a colorless gas, but it is having pungent smell. Pungent smell is unbearable, intolerable smell, and it is highly soluble in water. It liquefies at room temperature under a pressure of 2 atmospheric. So normally what the pressure is, it is 1 atmospheric. So if we take it to 2 atmospheric pressure, then what happens, sulfur dioxide gets liquefied. Okay, its boiling point is 263 Kelvin. Okay, now what about chemical properties? When sulfur dioxide reacts with sodium hydroxide, then it forms sodium sulphite. Now see here, what is the ion? SO3 2 negative, it is called sulphite ion. So what is formation? There is formation of sodium sulphite. Now see, if sodium sulphite undergoes oxidation, then it will form sodium sulphate. So we can say that we can prepare sodium sulphate from the sulfur dioxide gas if we treat it with a certain base. Okay, so from this reaction, one more thing you can see, this is oxide of sulfur, this is base, this is a salt, and this is water. So nature of this oxide is acidic, because acid plus base, it gives salt plus water. So SO2 is acidic in nature. Okay, now similarly, when it combines with halogens, it forms sulfuryl halide. Just like if it combines with chlorine, then it forms sulfuryl chloride. Okay, similarly, sulfur dioxide is oxidizing agent. It reduces hydrogen sulfide to sulfur. Now see, in this reaction what you can see, H2S has changed into S. So what happened to H2S? There is loss of hydrogen. Loss of hydrogen means oxidation. So here sulfur dioxide has acted as oxidizing agent. Okay, so what we can say, sulfur dioxide also shows oxidizing agent nature. Okay, now if we want to produce sulfuric acid, then sulfur dioxide is used. It undergoes oxidation first, then the oxide formed undergoes absorption, and there is formation of sulfuric acid. Okay, so there are so many uses of sulfur dioxide. Now few more reactions. If we treat sulfur dioxide with iodine, or we can say iodine solution, then there is formation of hydroiodic acid and sulfuric acid. In case of dichromates, if I treat it with potassium dichromate in acidic medium, then what happens? There is formation of respective sulfates of both the elements. Now see, which elements? Both the metals which are present in dichromate. Potassium dichromate if we have taken, then there are potassium and chromium metals present in that. So in the reaction, with the reaction of sulfur dioxide in acidic medium, there will be formation of sulfates of potassium and chromium. Okay, so chromium sulfate and potassium sulfate will be formed. Okay, now if sulfur dioxide is taken in a moist form, means In wet form, if we take it, then it behaves as reducing agent. Okay. Now what is reducing agent? Now see here what we have taken. We have taken sulfur dioxide in moist form. SO2 plus H2O means moist SO2. So what happened? Fe3 positive changed into Fe2 positive. So there is gain of electron. So gain of electron means there is reduction. So this mixture has reduced any other substance. So it means it also shows reducing agent nature. Okay. Now, okay. So this reaction is a convenient test for the gas. Okay. Now see what we want to say here, that if we want to check whether the gas is sulfur dioxide or no, then what we will do? We will take aqueous form of ferric ion and we will pass sulfur dioxide. In case it changes to ferrous ion, okay, then there will be change in color. Okay. So if there is change in color, then what we will say, that there is this particular gas was present. Now see here in this case, from this reaction we can make out KMnO4 has pink color when it is in solution form. Okay. So what it will do, it will decolorize acidified potassium permanganate solution. Now see here it is MnO4 negative, this is manganate, this is permanganate, MnO4 negative ion. So when sulfur dioxide in aqueous form is treated with permanganate solution, now here which permanganate is taken? Potassium permanganate. So the point is, when sulfur dioxide reacts with potassium permanganate, then it decolorizes it. Okay, decolorizes means it was previously light pink in color. So when sulfur dioxide gas will be dissolved, since it will change, permanganate ion will change into manganese ion, and because of this change its color will disappear, its light pink color will disappear, and we will say that decolorization has occurred, and decolorization is occurred because of the presence of sulfur dioxide. Okay. Now let us talk about its structure and uses. When we see sulfur dioxide molecule, then sulfur is the central atom, and in this sp2 hybridization occurs. Okay, there is sp2 hybridization. Now when sp2 hybridization occurs, then what happens? Then its structure is bent. Okay, so there is structure can be shown like this. See, this way we can show it. So with the two oxygen atoms, it shares bonds. Now see what happens when there is sp2 hybridization, then it retains one lone pair with itself. Okay, now see, if you see the structure, what we are seeing here, there is presence of one lone pair in the central sulfur atom, and it is bonded by coordinate bond with one oxygen atom, and there is formation of double bond with another oxygen atom. So what happens when there is sp2 hybridization in sulfur? Then there is presence of one lone pair in one hybridized orbital, and the other two, they contain single unpaired electron. Okay. Now when this happens, then those single unpaired electrons, they make bonds with oxygen atoms, and that lone pair which is present in a hybridized orbital, that is seen with the sulfur as lone pair. Okay, so now see, in case of sulfur, there are total 6 electrons in its valence shell. Now where those 6 electrons are existing in this structure, let us see 1 2 3 4, okay, 5 6, and this oxygen, its 6 electrons are these one, okay, and this oxygen, its 6 electrons are with itself only. So what does it mean? These 6 electrons are of sulfur, and these 6 electrons are of oxygen, and these 6 electrons are of another oxygen. Okay, so this way sulfur contains one lone pair, and on one side it forms double bond, on the other side it forms single bond, and this single bond is represented like this. But since there is phenomena of resonance, so we can write double bond this side also, that side also. So its resonance hybrid structure is like this, okay, and it is having a bent shape. So there is bent shape of sp2 hybridization in sulfur dioxide molecule. Okay, now what are the uses? Sulfur dioxide is a reducing agent, and it is used for bleaching and as a fumigant and food preservative. So sulfur dioxide gas, it is having these many uses. It can act as reducing agent, it can act as bleaching agent, it can be used as fumigant, and in food preservation also it is used. Now if we take large quantities of sulfur dioxide, then they are used for preparation of sulphuric acid in the contact process. Sulfur dioxide is used in bleaching wool or straw and as a disinfectant. So in place of chlorine also, somewhere in some places it can be used as disinfectant. Okay, liquid sulfur dioxide has been used in purifying petroleum products. So for the purification of petroleum products also we use liquid sulfur dioxide. Now it comes to most important topic, and the topic is preparation of sulphuric acid by contact process. Now there are 5 stages in this. First of all, combining of sulfur and oxygen. Okay, first is combination of sulfur and oxygen. So when this happens, then there is formation of sulfur dioxide. Then second is purification. Sulfur dioxide is purified. Okay, third is excess of oxygen is added so that there is formation of sulfur trioxide. Okay, now this is done in the presence of catalyst, which are oxides of vanadium. Now in the fourth step, what happens? This sulfur trioxide is added in absorption tower where sulphuric acid is mixed with this. Okay, it is sprinkled from the top and there is formation of oleum. Now in the last step, what happens? Oleum is diluted to form concentrated sulphuric acid. So these are the 5 different steps which are involved in the preparation of sulphuric acid. Now in equation form, if we want to write, then how can we write? First of all, sulfur is burnt, or from iron pyrite, oxidation of iron pyrite produces sulfur dioxide, or simply by burning or by combustion of sulfur there is formation of sulfur dioxide. Then what happens? Sulfur dioxide undergoes oxidation and forms sulfur trioxide. Now what happened? Sulfur trioxide is absorbed in absorption tower by sulphuric acid and this forms oleum. Then what happens? This oleum is diluted and this forms sulphuric acid. So chemically these 4 reactions are there only to write for the preparation of sulphuric acid. Now this is the process this is the flow diagram for the preparation of sulphuric acid. Now see, this is our first part and this much part is for purification. This is purification part, and this is oxidation part, and this is absorption part, and then our formation of sulfuric acid part. Okay, so combustion, purification, oxidation, absorption, and preparation of sulfuric acid. Okay, now let us discuss one by one. First, what happens? This portion is called sulphur burners. Here we burn sulphur and there is formation of sulphur dioxide. Now this sulphur dioxide formed is impure, so it is fed into series of these arrangements where it is purified. Now first of all, it is passed through washer. Okay, this is washing unit where water is sprayed from the top and sulphur dioxide, which is impure, that is fed from the bottom. As sulphur dioxide moves up, it comes in contact with water, and water carries away those impurities which are washable. So from here, when it comes out, then it is free from washable impurities. And now what we do, we again feed it from the bottom, and from the top we spray concentrated sulfuric acid. Its property is dehydration. So what it does, it absorbs all the water molecules, because when we are washing it when we are washing sulphur dioxide with water, then what is happening, it is becoming wet. So we want dry and pure sulphur dioxide. So what we will do, we will pass it through the sulfuric acid chamber, where sulfuric acid will be sprinkled from the top. It will absorb all the water vapors present in sulphur dioxide gas, and it will be dry. Okay, so now dry sulphur dioxide gas will be fed into arsenic purifier. Now what is this? Here what is taken? Ferric hydroxide. Here ferric hydroxide. See, here in this particular chamber we take hydrated form of ferric oxide. Okay, what is this? This particular substance absorbs all the arsenic impurities which are present in impure sulphur dioxide. So when it absorbs arsenic impurities also, then it becomes free from all impurities. Then what happens? Then we test the sulphur dioxide whether it is pure and dry or no. In case it is impure, then what we do, we again pass it from the purifying unit, and then again it will be tested. Once it is tested that it is dry and it is pure, then we will feed it in the oxidation chamber. Now what is going to happen? In oxidation chamber, in the presence of catalyst like vanadium pentoxide, sulphur dioxide will change into sulphur trioxide, and this sulphur trioxide, this will be fed in absorption tower, where concentrated sulfuric acid will be sprayed from the top, and then H2SO4 plus SO3 will result in the formation of oleum. Now what we are going to do? Now oleum is added in water, and then we will obtain sulfuric acid. Okay, so chemically there are only 4 reactions to be written in contact process. Now what are the physical properties of sulfuric acid? Sulfuric acid is a colorless, dense, oily liquid with a specific gravity of 1.84 at 298 Kelvin. This acid freezes at 283 Kelvin and boils at 611 Kelvin. It is highly soluble in water with the evolution of a large quantity of heat. Okay, it has more affinity to water, means it is easily dissolved in water. It easily mixes in water. In aqueous solution, sulfuric acid ionizes in 2 steps. Okay, when we talk about aqueous solution, then it ionizes in 2 steps. In the first step, what happens? One H positive ion will go and it will form hydrogen sulfate ion. Now this hydrogen sulfate ion, this is hydrogen sulfate ion, it again will ionize to form sulfate ion and one hydronium ion. Now since it is 2-step reaction, so for each step there is some value of ionization constant. For first step, if we say it is Ka1, for second step it is Ka2. So the overall value will be given by the product of 2. So it means this value will be larger value. Larger value of Ka indicates that the acid is stronger. Okay. Now, what are the chemical properties of sulfuric acid? First of all, this first reaction where cane sugar is treated with sulfuric acid and it forms carbon. This is also known as charring of sugar. CHARRING, charring of sugar. Okay. Now, when it reacts with formic acid, it forms carbon monoxide and water. When it reacts with sulfuric acid, it forms alkoxyalkane. Just like if ethanol, it reacts with ethanol, then it forms ethoxyethane. Okay. Now it also shows oxidizing agent character. When it reacts with copper, it changes copper into Cu2 positive ion. When we are saying that there is formation of copper sulfate, then it means Cu has changed into Cu2 positive. Similarly, sulfur changes to sulfur dioxide, carbon changes to carbon dioxide. When it reacts with benzene, this we are going to discuss in organic chemistry. When it reacts with benzene, now see, this is sulfuric acid. We have shown in the form of bonds. Okay, so what is going to happen? OH will go out, SO3H will attach. So from benzene, one H is gone. In the place of H, there is SO3H. Okay, that H and OH, they combine to form H2O. So this compound which is formed is called benzene sulfonic acid. Benzene sulfonic acid. Okay. Now, what are the uses of sulfuric acid? Sulfuric acid is known as the king of chemicals. Why it is known as the king of chemicals? Because if we want to see the industrial growth of any country, then we have to see that how much sulfuric acid that country produces and how much sulfuric acid that country utilizes in various industries. So because sulfuric acid is having use in each and every industry, just like it is useful in petroleum refining, in the manufacture of paint, dye, detergent industry it is used, in all metallurgical processes it is used, in batteries it is used, in lead storage batteries it is used. Okay, and it is a very important laboratory reagent. In the manufacture of nitrocellulose products it is used. So it is having very vast importance in almost all the industries. So we say sulfuric acid as king of chemicals. Okay. Now let us discuss about oxyacids of sulfur. Now see, oxyacids, as we discussed in case of phosphorus, there will be presence of these three elements. Okay, now we are talking about sulfur, so oxygen, hydrogen and sulfur, and that particular substance will behave as acid. Similarly, just like there, here also there will be bonds like SOH or SH bond. Now similar to PH or POH, this bond is ionizable and this bond is not ionizable. So as many SOH bonds will be there, they will decide the basicity of the oxy acid. Okay. Now see, just like if we talk about sulfurous acid, then there are two SOH bonds. So it means this molecule is dibasic. If we talk about sulfuric acid, then it is H2SO4 and there are again two SOH bonds. So again this is also dibasic. If we talk about peroxodisulfuric acid, then there are again two SOH bonds. So it is again dibasic. If we talk about oleum, which we discussed just now, there are also two SOH bonds. So it is also dibasic in nature. So what do we mean to say? That the substances, the acids formed by the combination of hydrogen, oxygen and sulfur are called oxyacids. they essentially contain S double bond O. Okay, they will essentially contain S double bond O, and there will be presence of either SOH bond or SO bonds. Okay, just like there in case of oxyacids of phosphorus, what was there? PH and POH bonds were there. Okay, similarly here it is that ionizable bond is SOH bond, that is ionizable. Now on the basis of what we have discussed, you have to solve these home assignments. Okay, thank you.